Hopefully everybody can hear me. Thank you for coming. People are going to keep filing in. I know the keynote ended a little bit late, but we're going to get started. So I can make sure that you stay on time for the next session, although this is the most informative session that you will attend at the entire summit. Hopefully you're at the right session. This is called Getting the Most Bang for Your Buck from EC2. If you're not at the right session, we're going to close the doors and lock it so you can't get out. No laughs. So my name is Joshua Burgeon. I'm the general manager for EC2 Spot, which is part of the compute services business. Wanted to thank you all for coming here today and for attending this session. I'm going to go over, at a fundamental level, how you use Amazon's EC2 purchasing options, which include on-demand, reserved instances, and Spot. As I mentioned, I'm the general manager for Spot. How you blend these together to get the most bang for your buck, the most cost-effective computing, the highest scale computing. But first, I'm going to go over a few fundamentals of AWS. One of these are what we call the pillars of performance and optimization. So there are 4 pillars. We're going to spend most of our time on the second one, which is the purchasing options. But I'm also going to go over right sizing, increasing elasticity, and how you can create a practice inside your organization where you continually measure, monitor, and improve. So what is right sizing? This seems pretty simple, but it's amazing when people transition from their on-premises environment to the cloud, how little sometimes they know about what their applications require. So right sizing is fairly simple. You simply select the cheapest instance available that meets your performance requirements. So if you're spending extra on a large instance with lots of RAM or lots of CPU or lots of disk or lots of IOPS that you don't need, you're wasting money. I know this seems very simple, but you'd be surprised when you move to the cloud how much you have an opportunity to kind of optimize and save money without any application re-architecture just by selecting the right instance. And I'll go into the different instance families we have a little bit later. The next is increasing elasticity. Obviously, one of the key promises of the cloud is elasticity, which most people think of as the ability to scale up to meet demand. Perhaps you have a web tier or an application where you need to get something done more quickly. But I also want you to think about right sizing as the ability to turn things off. This is another key opportunity you have in the cloud, and especially with AWS. So look at your environments. Do you have dev test machines that are not being used in the evening or overnight? You should turn those off. You're just paying for hours that you don't need to pay for. And we have tools like auto-scaling that make this very simple. You can kind of look for the CPU that's being used, look for what people are accessing. You can create events that determine when an instance gets turned on and off. So these are kind of really simple ways to save money in the cloud that don't involve a lot of application re-architecture. The next one is not a single activity, but more of a practice. So we call this measure, monitor, and improve. I don't know what your roles are inside your company, but typically speaking, if you're moving things to the cloud or if you're operating in the cloud, somebody's responsible for determining how things are going. Are we spending our money effectively? Should we be buying more reserved instances? Should we be using more Spot? Who's using what? We provide really excellent tools. One of them is called tagging that you can use to kind of identify your production environment, your development environment, who's launching things, what things are costing. And this can help you do those things that I was talking about, which is identifying the instances you can downsize. We can help recommend reserved instances to purchase. And then obviously, if you want to, whether it's just showing off or doing your job, you want to be able to dashboard how you're doing and report on your savings. We provide lots of tools, and a number of the partners that are out there in the expo, Cloudian, Cloud Health, Cloud Checker, they provide even more advanced tools that are based on the technology we provide that give you really granular information about what's going on in your AWS footprint and how you can optimize that for cost and performance. So a little bit before I dive into the purchasing models about our pricing principles. This seems very straightforward, but I think it's actually pretty revolutionary, especially if you come from the traditional IT and on-premises world. We don't require any upfront investment. So what that means is you can get started simply by creating an account on AWS and firing up an instance using our on-demand purchasing option. You could fire up hundreds of instances. Most people kind of get started with just picking one and starting. You pay as you go. You don't need to make a big commitment to us for 1 year, 3 years, 5 years to get some bare metal installed. But you can also pay less when you reserve. If you have the kind of business where you can commit and predict 1 and 3 years in advance, we offer significant savings when you commit to AWS. And the last, and I think this is really unique, is that you pay less when we grow. We do this in the form of extending price cuts to you, and we've had over 60 public price cuts since AWS started 10 years ago. That's just us taking your feedback and using our scale to offer more cost-effective and lower-cost computing to you, while you don't have to do anything to reap the benefits of those savings. So the good news is you don't have to take my word for this. How does this work in real life? I wanted to give you a customer example. So this is Novartis. They are a life sciences company. So they have an on-premises grid, and it was full. It was full of people doing work that had been planned, weeks, months, years in advance. Some scientists came up with an idea, an experiment that they wanted to try out. They wanted to scan 10 million compounds using a computational model, and their grid was not available. So they went to the IT department and said, here's what we want to do. We want to use 50,000 cores. When can we get this on the grid? And they said, you can get that on the grid in 18 months, and it will cost you $40 million because we have to build out a grid for you. Instead of just taking that as the answer, they turned to AWS, and they spun up something like 40,000 cores over 1,000 instances. This was several years ago. And they completed this research, this experiment. It's about 39 years of computational chemistry. It didn't take them 18 months to get set up. It took them about a week. They completed this research in just under 9 hours, right? They spent $4,200. $4,200, $40 million. Like you can take your pick. I think this is really cool. And the reason is not just that they save money, right? These are people doing life-changing research, trying to find a cure for cancer. And they can get faster time to results. So ultimately, that's what this is about. So now I'm going to dive into the meat of the presentation here, which is the purchasing options. And we have 3 of them. I've kind of mentioned them loosely: on-demand, reserved, and spot. The simplest one, as I mentioned, is on-demand pricing. This is low cost and flexible, requires no upfront commitment. It's perfect for your development, your test workloads, just getting started with AWS. If you have applications that are short-lived, are they spiky? Are they unpredictable? Can they not be interrupted? You're going to want to be using on-demand. You don't have to predict anything. As I said, you don't have to commit to us. You just pay as you go. In fact, all of our pricing is public, different pricing for different instance sizes. You can pick whatever you need, from our smallest instances to our biggest, the least memory to the most, whatever you want. That's the entirety of on-demand. If you don't understand it, there's more information online. The next one is reserved pricing, and I mentioned this before, where you can get a significant discount for committing to us. This is for your steady state workloads. If you're going to be running something 24/7, you're going to be running it for the whole year, or running it enough that it doesn't make sense really for you to turn it on and off. You're running your databases. You're going to be using reserved instances. So how does this work? There's really kind of 2 flavors of reserved instances, and they each share fairly common features. So we have our standard and our convertible RIs, as we call them. So with our standard RIs, you can make a 1 or a 3-year commitment and save up to 75% over those on-demand rates. You can pay all up front, partially up front, or nothing up front, and the savings differ. And then, as I said here, these are they also come with what we call a capacity reservation that is optional, that you can I'll go into the regional benefit in a little bit. Convertible RIs are very much like standard RIs, except over the life of your commitment, you can actually change the instance family, the size, the operating system, while maintaining that discount. So as you can see, there's up to a 56% discount over that kind of 3-year period. So these are really amazing, where you can make a commitment, kind of like leasing hardware, but change the hardware during the life of that and take advantage of new CPUs, GPUs, memory advancements. So that's a really unique thing and a unique selling proposition for AWS. So I mentioned this with a convertible RI. So you can convert to a new instance family. So you can go from R3 to C3, from our T2 instances to M4, pretty much anything as long as it's at least an equivalent kind of footprint to what you had before. You can change the operating systems, you can change the size, you can change the tenancy, you can even convert from no upfront to partial upfront. So convertible RIs give you a lot of flexibility, where you're still getting that discount for making a commitment, but you're not committed to one specific instance type and size. over that 3-year period or 1-year period. I mentioned all these instances. Some of this might be familiar to you. If not, I think it's very exciting. So when we started in 2007, as you can see, there were 3 instance types. And over the last 10 years, that's grown to over 60. So that's 60 instance types across 7 different families. So we have compute optimized, memory optimized, storage optimized, the low-cost instances. So all of these are give you kind of unprecedented flexibility to run any kind of application on EC2. In 2016 alone, we launched the P2, which are our high-performance parallel compute instances with up to 16 NVIDIA K80s. And they have these staggering statistics, like doing 70 teraflops of single precision floating point performance. It's not on this slide, but we've pre-announced our next generation compute optimized instance, which we call the C5, that has up to 72 vCPUs and 144 gigs of RAM based on the latest Intel chips, codenamed Skylake. So these things are fascinating. They're changing all the time. And the benefit of being on AWS is that you can take advantage of these things really easily. If you're using on-demand, you can simply stop your instance and then start it up somewhere else. If you've got a convertible RI, you can simply move it from one of these to the other, and you can kind of experiment for application performance. So back to reserved instances. There's one other thing that's really exciting that we've come out with in the last year, and that's this thing in highlights right here that we call the regional benefit. So a standard RI comes with a capacity reservation that's tied to a single availability zone. And just for terminology's sake, each AWS region is comprised of multiple availability zones, and availability zones are essentially isolated data centers that have interconnects between them, and you can kind of use multiple availability zones for higher performance and for higher availability. So the regional benefit is really neat. This slide is basically going into the details of what the regional benefit allows you to do. So let's say you run an application or a lot of applications on AWS, and you're purchasing RIs primarily to get the discount, right? You want a discount for 1 year or 3 years. You want that 75% discount. If you use the regional benefit, then the RI discount applies to all of the instances that match the RI that you purchased across all of the availability zones in a single region. So this is a really powerful tool if you work in kind of an IT planning or a finance function, and really you're just trying to get the maximum discount over all of the running instances you have for a single instance type. On the other hand, let's say you have an application that does kind of start up and shut down, and you absolutely need the capacity reservation to make sure there's no chance that that instance doesn't start up, then you're going to use what we call the sort of standard, the zonal RIs. So that still has the discount, and that RI is tied to a specific zone. And you can move these back and forth, and it doesn't have to cover all of your RIs. So you can have some reserved instances that are zonal and some that are regional, and we give you the flexibility to manage the business however you see fit. This is a really cool benefit, and once you get to a sizable footprint on AWS, people find themselves using this regional benefit a lot. Then the last, which is near and dear to my heart, is EC2 spot pricing. So spot is spare on demand that you can use for a significant savings. This is great for your applications that are time or instance flexible. Can you start up a little later? Can you use multiple different kinds of instances? Because the spare instances that are available vary across instance types and availability zones. Are you running an experiment like the one that I mentioned at Novartis? Do you have an extremely cost-sensitive business where maybe you need a 90% off savings from the on-demand price, and maybe you're highly spiky? You need lots of compute capacity. We have tons of examples, and they're really cool, and I'll go into them later. So spot, as I mentioned, can be up to a 90% off savings compared to the on-demand price, so that's significant. And that's even greater than the RI savings, and it doesn't require any commitment. This is great for your elastic workloads that are going to scale up and down significantly, where you don't have a baseline of kind of consistent use over the 1 or a 3-year period, so you're not going to want to make that commitment. We have APIs and tools like Spot Fleet, which is going to help you kind of set up a fleet of Spot instances. Let's say you needed those 30 or 40,000 cores across 500 or 1,000 instances. We're not going to make you do all the work of finding where those instances are and figuring out exactly how to maintain them. We provide tools like Spot Fleet and auto-scaling. And as I mentioned, the commitment level is none. So I'm going to dive a little bit more into detail because Spot has a couple nuances that are important to understand. At a fundamental level, it's a market where the price of the compute changes based on supply and demand. You will never pay more than your bid. This is an important concept to understand. It sometimes trips people up. So in this instance here, this is kind of our public price history API and a graph. No matter what you bid for the Spot instance, you're going to pay the market price at the time. So in this example, the market price is 15% of the on-demand price. So that means no matter what I'm bidding right now, I'm saving 85% over the on-demand price. And the only time my instance is interrupted over the course of a week or a day or sometimes months is when that price exceeds whatever my bid is. So let's look at how that looks in practice. If I bid 25% of the on-demand price, I say that's the absolute maximum I'm willing to pay, I still save 85%. And then there are a couple times you can see where the little blue line kind of crosses over the black line, the market price exceeds my bid. That's when my instance is interrupted, and you get a 2-minute notification, which is your opportunity to kind of wrap up the work, write the data to disk, and then maybe go off and do something else. So you're saying that's great, but I don't want to be interrupted so much. Maybe you bid 50% of the on-demand price. Again, over the course of a week, that's how long this graph covers, this person who bid 50% of the on-demand price saved 84% instead of the 85%. Only 1% difference, even though they were bidding twice as much. And they only got interrupted once when there was this kind of shortage and price spike right here on the graph that you see. So I'll take it one step further. Let's say you bid 75% of the on-demand price. So this person still saved 84% over the entire week, and they didn't get interrupted once. So if you're using Spot or you're thinking about it, don't spin up a department full of PhDs to figure out your high-frequency trading algorithm on bidding. Just bid something like 75% or 100% of the on-demand price. You're going to save typically between 70 and 90% off the on-demand price. You're going to face the least amount of interruptions. And then really you're going to use tools like Spot Fleet to kind of maximize the availability that you have across the different spot markets. So this is super simple. Remember, you only pay what the market price is, not what your bid is. We also provide tools like Spot Advisor, and this is available on our console. It's free, where you can basically tell us what kind of application you have. Do you have a web service or some kind of stateless front-end API tier? Do you have a MapReduce job? Do you have a batch job? Each of these are going to have different Spot Fleet configuration settings, but you don't have to figure those out for yourself. You can just plug it in here, and we will recommend a fleet for you. The coolest thing is that this is also integrated into the ECS console. So if any of you are using the Elastic Container Service for your microservices, your Docker, you can simply go to define your tasks and then get a fleet definition for you, and then kind of off you go. And that'll recommend bids and all that kind of thing. So if you maybe fell asleep during part of this presentation, you can just go back to the console, punch a few buttons, and off you go. And if you're more the engineering type, after you push these buttons, there's always an option to export it to a JSON configuration file. So then you can download that JSON config and then plug it into the API. And maybe you're using an application infrastructure where you want to edit that. So this is really cool. It's kind of how we do things. So now I've gone over the three models, right? We have on-demand, we have reserved, we have Spot. And you're saying to yourself, which one of these should I use? Answering that is like saying, what's your favorite food? And then eating only that food for the rest of your life. You need to have a balanced meal. Although whichever one of these is your favorite food, that's Spot. Yeah. You're not going to choose just one business model. You're going to mix them all together. So you're going to use reserved instances for your known and steady state workloads. You can set up multiple auto-scaling groups to mix between reserved and on-demand or Spot. You can scale up using Spot, on-demand, or both, depending on your application. And I'll go into exactly how that works. Your graph might not look exactly like this, but this is the most powerful tool for you for optimizing your cost and performance on AWS. So here's an example, and I'm going to go through two different application architectures. The first is what I would call a 3-tier web app. And this could be an API tier or a stateless website. They all share kind of fundamental building blocks here. So what you see at the front is kind of an elastic load balancer that's handling traffic. And it's putting traffic across multiple availability zones. I mentioned those earlier. And that's for your higher availability and getting closer to your customers. Then maybe you have another elastic load balancer or some kind of traffic manager that's taking requests and putting it to your stateless middle, your stateful caching tier in the middle. And on the back end, you have some kind of persistent data store or data layer. In this case, I'm using S3 with cross-AZ replication built in. So I mentioned this earlier. The first thing you're going to want to do when you set up any application architecture is make use of tagging. Tagging is free. It's really powerful. It's really flexible. Tagging is very simple. It's basically key value pairs. In this example, what I did was I set up who the owner of the box is and then what stack it is. So I can know who started the application and what part of my application. Is this production? Is it dev test? Is it part of the web tier, the cache tier, the database? And what that gives you the ability to do is determine like how big is my dev environment? How big is production? How big is my caching layer? What's running? Who started it? So you can get up to 10 of these per instance. And there's all kinds of ways to use this in the reporting, and all of the third parties I mentioned earlier, they make extensive use of tags. So tagging, tagging, tagging. So how does this look? So our web tier, if it's well designed, is what we would call entirely stateless. This means you're treating your EC2 instances as cattle, not pets. So if one of them comes or goes, or you need to scale up or down, this doesn't kind of bring your whole application to a halt. So in this case, you're going to use reserved instances for your known steady state workload. If you know, like in this case, you needed 100 instances to serve your customers no matter what time of the day, your best bet is going to be buying reserved instances to cover that. There's kind of no application architecture to think about. You're going to get significant savings, and you're not going to turn those instances on or off. But then for these peaks during the day, again I mentioned it's entirely stateless, you can make heavy use of Spot. So these Spot instances, as I mentioned, they carry with them the possibility of being reclaimed or terminated, but you get a 2-minute notification. Well, if you're running a stateless web tier and you're serving your application in 100 milliseconds or 200 milliseconds, that's more than enough time to serve the requests you have, to drain from the load balancer, and then kind of redirect requests to the new instance while you're spinning it up. Maybe for the last peak of the day, you find that you need on-demand instances, but you can make heavy use of Spot when you have a stateless web tier. Then we have that next layer that I talked about. Maybe this is your stateful application tier that provides a cache for higher performance for the front end. Since it's stateful, again, if it's running 24/7, you're going to make heavy use of reserved instances. Then in the middle, as I mentioned, it's stateful. Let's say this application has to be up for 6 hours at a time, or 8 hours, or 12. You kind of take a look at what your load is, and you use on-demand for that period of time. You're still going to turn these on-demand servers off using maybe auto-scaling groups to spin them down when they're not being used. And then in the last case, you can still use a little bit of Spot. I kind of glided over this earlier, but we have a capability we call Spot blocks, which are Spot instances that you can ask whether they will live for at least 1 to 6 hours, and then they're kind of designed to run continuously for that period of time. So you're always looking for opportunities to kind of tier your savings. And the last is the database tier. So I'm only going to say this once, which is you do not run your databases on Spot. If you do, I will not answer your trouble tickets. You run your databases on reserved instances. So again, regardless of your kind of ups and downs during the day for your databases, you're running them on reserved instances because you don't take them up and down. But what's cool about the cloud is there's still the opportunity to use elasticity. Let's say at the end of every night, or the end of every week, or the end of every month, or the end of every quarter, you have some big kind of ETL or batch job to kind of process all the data and maybe move it into a data warehouse or get it in some kind of front end where people query it. Typically, people in an on-premise environment will create maybe an entire standby database and run it all the time. You can replicate that behavior here, but not have it running all the time. You can spin up an on-demand instance, kind of take a read-only replica copy. Maybe you even do your reporting from that, or you do your ETL, and then you shut it down. So it's a lot more cost-effective to only be running this instance once a day for an hour, or once a week for a day, or once a month for a couple of days. This is a really powerful way to not have to have duplicate infrastructure running all the time just because you need reporting maybe a few hours a week. So this is very common. So this is our summary for this hypothetical 3-tier web app. So I have this balanced meal concept I mentioned before. across everything that I was using, I had 76% reserved instances. And these aren't specific percentages. I'm just giving you an idea. 13% Spot and 11% on-demand. So it's kind of roughly balanced for my Elastic workloads between Spot and on-demand. The last thing you want to think about, and if any of you went to the keynote, you might have heard Werner talk about this, which is this phrase that he likes, which is, no server is easier to manage than no server. So maybe, while you're thinking about servers, you can also think about which parts of your workload you can offload onto AWS. Maybe you can use SQS, or a simple queuing service, or Lambda, to kind of handle functions that you really don't even need a server for all the time. They're just functions that get requests and then do work. So how does this look like in real life? Again, I like to use these customer examples. Hopefully they resonate with you. Ubisoft is a Paris-based gaming company. They're in the business of creating hit games. Now, it would be great if every game was a hit, but that's unfortunately not possible. So what they need to be able to do is iterate quickly and try lots of different experiments, but then not have to live with the collateral damage of those failed experiments. If you have to buy hardware and plan in advance like everything's going to be a hit, you might be stuck with that hardware for the lifetime that you purchased it. You don't have that problem with AWS. Also, Ubisoft is able to move faster. As you see from the quote here, they were able to launch 10 social games within 18 months. They were able to get out of the cycle of planning based on their infrastructure, of being stuck with the guy who says, well, the infrastructure's full. You should have asked me 6 months ago. That's my planning cycle. Or you have to go talk to the other game that's going to be using your infrastructure. You don't have to think about that anymore. So now into the next example, and this is a super broad area. I'm calling it grid processing, but it could be grid or batch or HPC. Rendering workloads kind of fall into this. It's the collection of computing resources from multiple locations that are kind of coming together to reach a common goal. So if you have a scheduler or Hadoop or Spark or any kind of batch workload, it's going to fit into this framework. So you have at the front end lots of little files that are stored in maybe S3 or a Fuse layer. And then you have your grid of computers that are EC2 in this case. They process everything, and then they pull it all together on the end, and it turns into a result. So this is how you would do this in the old world, in the on-premises world. You have to figure out what your actual demand is for computing. It varies over time. If you're a growing company, it's growing over time. You have to buy the servers ahead of the need for the actual compute. So this would work really great if you had perfect prediction ability and you were able to always buy to the absolute peak of your needs. I've never seen this in real life. This would be a super cool graph. This is what it looks like in real life. You predict what your peak usage is that you can profitably afford to buy servers for. That's what you purchase. You also can't predict everything in advance. You don't always know what your peaks are going to be or when the valleys are going to come. So you purchase hardware, you onboard it, you get it ready for people, and then somebody comes in who needs more compute than you purchased or more compute than you can afford. What do? You delay them, right? So that's real impact to real people. Now, before I go into too much depth, you can replicate this exact process in the cloud. Remember those RIs I mentioned earlier? You can buy 3-year RIs every time you know you need new compute, you have new compute use cases, and just keep stair-stepping up every time you want to. That would be kind of the simplest way to get going. But you don't need to do that. So when central IT is looking at your grid, what they're trying to do is maximize utilization. This orange line here, when their bosses are looking at them, they want to keep grid utilization at 100%. It's used all of the time. You see this dip here when it goes down to 20% when nobody was using the grid? That's when the IT boss comes in and says, like, what's happening? Why do we have all these idle compute units? But the business looks at it entirely differently. I mentioned those delays. So every job in the queue, I've kind of flipped the lines around. So every orange job in the queue here represents business impact. These are your users that are sitting there waiting for their work to get done. So you have IT trying to keep grid utilization at 100%, which means jobs are waiting, and then business users that are trying to get work done. It's kind of this cross purposes here. So how do we do this in the cloud, besides buying reserved instances for 3 years at a time? So we can give you access to higher capability, higher capacity when you need it through things like Spot and on-demand, accelerate those projects, and actually generate new demands for computing inside your organization. faster agility, shorter wait times, happier users, quicker time to results, right? That all sounds great. So this is what it might look like. You're still purchasing your reserved instances at periodic intervals as you kind of predict your long-term demands for computing. You're mixing in on-demand as new applications are onboarding to the cloud, ones that can't be interrupted or where people are just getting started out. But then you're using spot at intervals to scale up sometimes 10 or 100x whatever your footprint is without any commitment, without any huge financial outlay. And these people are just getting their work done. I mean, I think this is great. You can even go one step further as you get a little bit further along. You can use those spot blocks that I mentioned and even further shave off some of the peaks of your on-demand usage. So why does this matter? It matters because you only want to be constrained by the speed of your thought. This is a diversified financial services company based in Australia, Suncorp. And the way they're using AWS is to kind of be more effectively constrained not by the infrastructure, but only by the speed of their thoughts. So they're supporting kind of 14 different brands across 4 lines of business in 5 countries. And they kind of wanted to think of themselves as innovative. And they take pride in their talent. So why do you want your talent to be constrained by your infrastructure? You don't. So how does that look like? I've given you a couple examples. We had gaming. We've had other people. There's a lot of different industries in this room, so I kind of wanted to give you a few patterns that perhaps you can use that might resonate for you, that how can I think about this for myself? So one example here is a web-scale company, AdTech. So these are companies that are perhaps doing real-time bidding, which are transactions that have to happen in maybe 50 or 100 milliseconds. Some of these companies are doing 50 billion transactions a day. So when you're doing 50 billion transactions a day and they only take 50 milliseconds or 100 milliseconds, you can be entirely stateless. Those companies make very heavy use of spot. They're also in kind of very cost-sensitive businesses where the cost per 1,000 advertising units is always being driven down. So they're always looking to optimize. We see these customers making super heavy use of spot, and because their businesses are highly variable, comparatively less amount of RIs. So this might be if you're highly spiky, you're brand new, this is what you look like. On the entire other side of things, maybe you're an enterprise software as a service company. You're looking to move to AWS, get out of your data centers. Maybe you have a monolithic application, right? It deploys entirely kind of on one box. It's totally stateful. In that case, every time you get a new customer, maybe you're signing a 1 or a 3-year contract, you can buy RIs that are based on that, and that's why you're going to see a footprint that looks like this. You're buying RIs, you're using on-demand for your proof of concept with new customers as you're trying things out. Maybe you can't make heavy use of spot. But what you can see here for this company, and these are real-world examples, I just took off the company names. Over the course of a year, they started doing more analytics. They started moving their monolithic application to a microservices infrastructure. So they're already starting to experiment with spot, and that you can see kind of up there in the corner. Now I'll give you another example of what I would call an onboarding enterprise. So this is somebody that's trying out AWS. Maybe they have a few departments using it. So they purchased some RIs for some application that they're going to move entirely to AWS. Kind of see that as a baseline here. And then there's some guy or gal off in the corner building a new application. So how do they get started? They use on-demand. Fire up some on-demand instances, start running the application. Maybe the application gets successful. So they're using auto-scaling. It's spinning up more instances and more instances. You can kind of see this blue bar kind of growing up. Towards March in this year, somebody in finance looks at the bill and says, why are we running all these on-demand instances? What's happening? And they realize this application has been highly successful. So what they do is they make a big new purchase of reserved instances for this application. You can see the RIs kind of jump up, and then the on-demand usage as a percent goes down. But the cool thing is that innovation wasn't throttled. This person sitting in the corner, in my example, sitting in another office, is able to get started, build a new application, be innovative, without getting blocked by kind of a long purchasing cycle. Another example, I used gaming, and before I came back to AWS, I actually worked at Zynga for 4 years, and this is a very common pattern where, again, you don't know if your game is going to be a hit or your new service pack or your release. So you have kind of a baseline of RIs, and when you do a big new release, you have a spike. That spike might last a day, a week, a month. It might be a new level, baseline of usage, in which case you're going to buy more RIs. But if it tapers back off, you haven't made a costly commitment that you're upset about because maybe your game wasn't a hit, unfortunately, or maybe the usage only lasted kind of some period of time. Next is scientific research. And this graph is a little bit deceiving. It makes it look like they don't use very much AWS. But this is that example I gave earlier, where we have people like Brookhaven and Fermilabs who work on the Large Hadron Collider, kind of discovering new particles and the origins of the universe. So they're humming along. Maybe they're using 100 or 1,000 instances as their RI baseline, maybe 10,000 cores, just as an example. And then somebody comes along with a brand new experiment that wasn't planned and spins up a 150,000 core cluster and runs it for the course of a week. You'll see this massive spike where your footprint has just gone up 10x for the course of a week. You run some experiment, and then you shut everything back down. That's a super powerful use case, and it's really something that's just not possible on premises. So I think this is really cool. And the last is what I would call your generic technology company. Maybe you've gone all in on AWS, some of the examples that Werner was talking about across your different divisions. You've got your Exchange servers and your SAP and your CRM. They're all running on reserved instances. You've got your web tier and your analytics running on Spot heavily. You've got on-demand for applications that are stateful or where you're trying things out. You can kind of mix and match these things, which really brings me into my kind of final point about different industries. You may actually find that you don't look like any one of these patterns, but the different departments inside your organization each look like this. So data science is kind of a common theme. You're going to make heavy use of Spot. You need to be able to scale up and down very rapidly. You can't predict your workloads. You need urgent access to compute. And you have lots of kind of grid processing or batch. You're going to use heavily Spot-based workloads. The new app development person that I mentioned, you're going to get started maybe with as little as a single on-demand instance, or maybe 2. Internal IT, those applications I was talking about, Exchange, SAP, Oracle, your monolithic SaaS applications that you purchased or are running, they're running on heavy base of RIs with some amount of on-demand for kind of peaks and valleys. Again, that's because they're highly stateful. It would be a disaster if you got data corruption because the application was interrupted. And then for test and development, maybe you're running continuous integration or continuous deployment. Maybe you're using Jenkins. There's actually a Spot plugin for this that makes it one click and you're saving money. You're using heavily Spot and OD with only a little bit of RIs. It doesn't really make sense for your test and development, except for like the really small base layer, to be buying RIs that are running 24 hours a day and 7 days a week. Hopefully this is resonating with you, and when you kind of think about your applications and your workloads, you start thinking, in the beginning, what do I need to get started here? Do I need an RI? Do I need on-demand? Should I just be firing up Spot? What kind of application is this? Can I optimize because it's stateless and I should be moving a significant portion of it to Spot? Can I actually just turn things off at night, even though it's stateful and it's running on-demand? Can I optimize my costs by doing a little bit of prediction over the next 1 or 3 years of what my usage is going to be and purchase more RIs? And that's going to be a practice that serves you really well over time. This isn't something you do once and then forget about it. So because I want to leave time for questions, I'm going to recap what I've gone over here. I mentioned there were pillars of optimization. There were 4 of them. So right sizing, that's picking exactly as much instance and no more than you need for your application. Increasing elasticity. So again, this doesn't just mean scaling up when you need it. It means scaling down when you don't. You would be surprised at how many people are able to save sometimes as much as 50% of their technology spend when they're moving from an on-premises data center to the cloud by looking at applications that are running now on instances inside of EC2 when they don't need to be. The calculus really changes in the cloud. Measure, monitor, and improve. As I mentioned, this is a practice you're going to put into place using tagging and all sorts of other fun things. Tagging. 10 key value pairs, they're free. You don't have to tell anybody they're free. You can tell people you found this amazing thing and you're using it only for them. And they're kind of really cool things you can do with the key value pairs. They're strings, so you can put whatever you want in them. I find that people who are the most optimized are the ones who are making really creative use of tags and thinking about What do I want to know about the cost of my application or the cost of my footprint, or maybe down to the cost of a single department or a user? There are those 3 core purchasing options: spot, on-demand, and reserved instances. You're going to want to have a balanced meal. If you're only using one, chances are pretty good you're missing out on an opportunity to optimize. With spot, you can save up to 90% off of on-demand. With reserved instances, you can save up to 75% off the on-demand. So when you kind of think about pulling these things together, that's how you're going to get the most bang for your buck. And the last, and I didn't spend a lot of time on this, right? But it's architecting your workloads with performance and cost in mind. Now that you understand how all of these things work together, as you get more familiar with AWS and you understand not just the purchasing models, but our different instances, take a look at your application. Does it need to be running 24/7? Does it need to be stateful? Does it need to use 100% of the CPU? Or could it be running on a T2 instance where it only needs to burst for the CPU for small periods of the day? These are opportunities, in some cases, even without a lot of prediction, to turn your application from something that's running 24/7 on a very large footprint piece of hardware to something that's entirely stateless and can run on almost any instance. There's a number of other sessions that are here. There's lots of things on YouTube last year from reInvent where we have customers like Lyft and Mapbox that are running significant portions of their application architecture using Spot and other kind of highly dynamic services like Lambda and SQS, where they've, using microservices and other techniques, really got their footprint down to really tight tolerances. And that gives them a lot of agility because they're saving money they can use for other things, right? It's more margin for your business, or more cost savings allows you to compete in ways that your competitors can't. So you can think of this last thing where it's architecting your workloads as a way to give you a competitive advantage in the marketplace. So how does that all come together here at the very end here? I fully believe this statement that AWS is more cost effective, both in the short term and the long term, than on-premises environments. So you can leverage the 3 EC2 consumption models to gain the freedom to build unfettered. You don't have to say no to people because the infrastructure is fully used up, or it would be too costly to make a big new purchase or refresh your hardware, or try something out. You get the freedom to get real value from your data. I've talked a lot about cost optimization and performance optimization, but really what you're trying to do is make your website faster so it's more performant for the customers, or run more experiments and get the data back more quickly and then do something with that data. That's the freedom you want. And then lastly, as I said, it's the freedom to say yes. So no matter what role you're in the company, if you're a developer, if you're in finance, if you're in IT, new application development, if you're in testing, you want to be able to try new things. You want to not have to live with the collateral damage of those experiments. And that's really what we're all about here at AWS. So in closing, I wanted to say thank you guys very much, again, for coming out here. I traveled all the way from Seattle to meet all of you, not yesterday, but recently. And I always find it fascinating to kind of hear your stories. So we have about 5 minutes left, and I'm going to be available for questions. And thank you very much.